Welcome to Maritime Matters, a podcast focused on leaders in the maritime market, the people, the companies, the technologies that are making and breaking the news, helping to lead the maritime industry to a safer, more efficient, more profitable, and cleaner future. Welcome aboard. And we're very pleased to be joined by Peter Duclos, Gladding-Hearn Shipbuilding, Winn Willard, and Robert Provencal of Ray Hunt Designs to discuss trends in pilot boat design and construction. So, gentlemen, as I wrote to Peter when I proposed this interview, when I think of pilot boats, I think of Ray Hunt Designs and I think of Gladding-Hearn Shipbuilding. I know that both of your organizations are much more broad than one boat class, but can you put in perspective the importance of pilot boat design and construction to your relative organizations?
You were in pilot boats before we were in pilot boats, Peter.
Yeah, okay. So,
you
yeah, I'll start it off. Yeah, so it
when
goes
did
back,
Gladding-Hearn get started?
it goes back to 1957 for Gladding-Hearn. We had been building small steel tugs, and it was really the advent of the rubber fender coming out of World War II. Large extrusions that made the small pilot boat, steel pilot boat possible. Before that, they were all wood. And because they were worried about creating a spark alongside a gasoline ship or tanker. So the Delaware pilots saw one of our tugs either in a magazine or something like that and said, hey, that looks just like, very close to one of our wooden pilot boats. Can you build us, here's one of our, come look at our wooden boats. Can you build a steel one? So Mr. Gladding and my father went down and looked at it, and they came up with a 10 knot single screw of displacement launch, pilot launch. And today, even today, those are, in my estimation, the best sea boats I've ever been on for a 48-foot boat. I'd take one literally anywhere. They're like a schooner without a mast. The very deep keel, lots of concrete in the bilge, and they're just so comfortable. But only 10 knots, right? So then fast forward to we built quite a few of those over the years. And then fast forward to the early mid 70s, I think it's 77, 78. Again, the Delaware pilots came to us and said, hey, we love your boats, but we want to go faster. And you really need to work with these guys at C. Raymond Hunt. They make, great offshore boats and, high-speed boats. So then Winn, you take it from there.
That's how we got into it. Brett Gladding got in touch with us and said, well, I can make a boat go 15 or 18 knots, but you guys can make them go 20 knots or more. And let's have a collaboration. And so we did. And the first boat in 78 for the Delaware pilots, they were the leaders in it, really. And so the first boat went 20 knots and steel, the aluminum house, couple of 8V92s with not a whole lot of horsepower in them. And they've evolved ever since then to now, I think it's over 80 boats that we've done of all sizes, but and it's progressed from steel to aluminum mostly, almost entirely now. So, and as far as its importance to our business here at Ray Hunt Design, it's a big chunk of our business, probably 20 or 25% of our business has been pilot boats.
The Hunt Deep V design, it's renowned. It's built on those 60 years of design experience, as you discussed. So can you give a brief overview of the Hunt Deep V? I guess what makes it unique? How has it evolved, and what makes it particularly well suited for pilot boats?
Mm-hmm. Sure. Well, Ray Hunt came up with the high dead rise hull design in the late 50s, early 60s, and patented it, actually. If you study his designs prior to that, you can see it evolving towards the V. But basically, he showed the world that you didn't have to have a flat bottom to go fast. Up until that time, all high-speed boats were basically flat bottom, which is fine if the water's flat. But in real offshore conditions, they couldn't go fast. And so he showed basically if you keep the buttocks of the hull straight in a V or a flat, it didn't matter, the boat will plane. And so he came up with a hull shape that was both fast and capable in rough water, is what it amounts to. And thus making the faster pilot boat possible. It's still very much similar to exactly what Ray drew in the early 60s. We've evolved it to be different for different applications, and we've learned a lot in 60 years, so we can apply the shape to a lot of different kinds of boats.
And as you know, each local waters has its unique operating conditions. I guess, can you discuss in the round the process by how you work with each individual clients or clients to analyze local conditions, then
Yeah.
structure a design and build with unique characterizations?
Yeah, I can start this, and I'm sure Bob will add to it. But yeah, they all vary quite a bit. Basically, they all have their way of doing things, and it all comes from the geography, really. How long their run is, how long they spend on board. Some of the boats are very simple. In fact, back in the day with the small, the single screw steel boats, you had a compass, a couple of pilot seats, and a rubber fender around the boat, and that was it. That was a pilot boat. And then of course, now that they're almost everything has a wire attached to it, right? They're pretty complex. They have very, very high end seats to deal with the higher speeds of and it's all about getting really, and the point of going fast is to do more with less, right? It's to cycle the expensive part of the whole process is the pilot, right? So if you can move the pilots faster and have them do more ships in a day, it's more efficient. So that's really the whole point of going fast. And when you talk about in terms of comfort on a pilot boat, it's do I feel safe? Am I gonna, land on the deck and hurt myself? And am I gonna be all stressed out and have a twisted back by the time I get to the ship, right? That's you can't have that, right? So comfort in terms of pilots is a very high threshold compared to the typical person off the street. They go out when it's when nobody else will go out or want to go out, so it's all, that's really what it's all about. But at the end of the day, while they all vary in terms of their arrangement and they all do the same thing. They come alongside. They have to come alongside a ship and get away from the ship. Put a pilot on. Do that safely, predictably, in all kinds of weather. So you need a really good fendering system. The visibility has to be really good. The boat has to handle. And you have to have all the handrails in the right spot. The pilot has to be able to see the operator. The operator has to see the pilot, and the crew member on deck, and all those things. If it doesn't do that well, it's not a pilot boat. So beyond that, the creature comforts and the things that vary and the arrangements that vary with geography. Some of the runs are 26, 30 miles. Some of them are just a few miles, right? Some of them are live aboard. Some are very simple day boats without even a head on board. So, and that's where really Bob comes in to a large degree, where when we get the requirement, he and I will sit together and look at some of the boats that we've done, right? It's kind of like this one, a little bit different here, and you combine it. And at this point, there's probably pretty much, we've done just about everything you can do, but it still has to be all put together in one package so that it can be built by humans, So, and that's what the collaboration really is between Gladding-Hearn and Hunt.
Well, a little bit of history, if you will. This relationship started out before I came to Hunt. I actually started my career at Gladding-Hearn. So I know the Duclos well. I worked for the Duclos. I worked, Prick Gladding was sort of my mentor, right out of high school. And what I like to tell people, I walked into the shipyard not knowing which end of the tape measure to use first. So I learned a tremendous amount of knowledge there, and then brought that with me when I came to Ray Hunt, and that was nigh on 40 years ago. So, but that relationship continues today, where Peter and I, or the first phase are Peter and I will go over the contract or the specifications, and it works so well that we can anticipate each other's conversations or requests, and then in the build phase, that continues with Peter's brother John, and it's the same relationship where we can almost anticipate what one another are going to say or do, and so it works very fluid. It's very laborious. We've tried to come up with a standard arrangement, and as Peter says, it just doesn't work. Because they all have their own little ideas and practices. And I will say right off the bat, every port in the country has the worst conditions in the world.
Yeah.
Yeah.
And it is probably true on some given day, right? Everybody has their weather, right?
That's right.
Yeah.
And another bit of history was those smaller single screw boats spent a lot of their time offshore, tied up alongside a mothership or the pilot station. Back in the day, the pilot stations were offshore.
Right.
And that's one part of the pilot boat story that is significant in that. In fact, on the wall behind me here in my office is a photo of the Boston pilot boats in 1967. They were still wooden schooners, and they lived.
I left that out.
Yep.
They lived offshore, the port of Boston, and the pilots were taken over from the schooners in about an 18-foot rowboat with an outboard motor to the ladder on the ship, and the ship had, of course, had to come to a complete stop to allow this to happen. So the change to a high-speed launch just almost has entirely eliminated the cruising pilot schooners or ships that stay offshore. I think San Francisco, New York, and maybe Houston are the last three that use pilot
station boats
that stay offshore. Yep. Everyone else has shifted onshore, which has saved them a lot of money, saved the pilots, the shippers a lot of money by going to these fast launches.
And the ships don't have to slow down. They're boarding at 10, 12, 14, 15 knots, depending on the conditions.
Right. So it's been a benefit. These little boats have been a benefit to the entire industry, really, because of that one change for the most part.
Peter, I love your comment that every port has the worst conditions.
Well, they do, and it's true. And the other little thing I have to say is, we've got what, over 100 pilot boats, and we've designed the perfect pilot boat 100 times.
Yes.
And you say to yourself, gee, why would anybody want anything different? Well, somebody comes up with another thing, but that's what makes us better. I think, our customers are our best teachers, if you will. They push us to do different things, and they have the confidence in our team to get them right.
Peter, with that, you gave a great overview of the pilot boat, or the pilot ask. You knocked down, bottom line, they want to get to and fro safely, efficiently, in good condition. So, with that, I guess can you all discuss some other prevailing trends in pilot boat design and construction? And again, I look at our pages on a daily basis, and we're talking about fuel transition, we're talking about hybrid propulsion, we're talking about automation and autonomy ad nauseum infinitum. So I guess, and is it, I don't know if it's a fair question, but what do you see the pilot organizations looking for holistically? And I guess which technology evolutions have substantially changed the design and build and performance in the past decade or so?
I think I can start this. Well, first of all, pilot organizations are very traditional groups. There's not, I've found, and it's not a criticism, but it's like being on a ship. And it's not a lot written down, right? They just do what they've done year after year after year, and they run like a ship, 24 hours a day. So it, they don't, then they're sort of adverse to change and risk, and some more than others. So that's the other thing that drives, the designs that we do. There are some groups that are a little more open to newer technology, and they're the ones that I would say today are building things like the boats powered by the pods, IPS, Volvo Penta IPS system. That's probably the newest trend. Um, but there are also at the same time pilots that say, yeah, that's not going to work for us. We have debris, we have ice, we have, whatever. We don't, we're in the middle of nowhere. We can't get service. And so uh, that's what drives it. So, but I think that the newest technology is probably the Volvo Penta IPS system. We started off with propellers, conventional propellers, and we still build a lot of those. We built some jet boats. We still build some of those, and we have the IPS boats, and they're well and truly, the IPS boats burn 30% less fuel. No magic. And I'm not sure why people aren't really jumping up and down and saying, I got to have one, because that's what's measurable, is real. And and we've looked at similar applications for things like hybrids and batteries, and the energy is the same, if not higher, because when you putting batteries and make a hybrid system, the boats get heavier, they're small, and they're not necessarily more efficient, right? Where are we going? What's the future? I think perhaps certain applications you could use a battery only boat for certain runs. I think, in my opinion, hybrid is not the right application for what most pilot boats do. It's because they're either on or they're off, typically, and there's not a lot of loitering. And from what I've seen, hybrid applications are best for when there is a lot of loitering.
I think,
Well, you guys.
I think the other technology that's coming in is control over the boat. Like ride control is now pretty standard on a lot of our boats. We use interceptors with the ride control function more and more. And
Gyros.
yeah, and then there's the gyro that comes in
Good. Yeah.
as part of that. And all of that is just making the boat more comfortable and more efficient. With the ride control system, you can adjust the attitude of the boat to speed, and thus you definitely should. Usually the ride control system is partnered with the pod drives, and so
Right.
together they make for a pretty efficient package.
Yeah. If you look at the Galveston boat that we delivered going on 2 years ago now, that had all of that. It had gyro, ride control interceptors, IPS pods, and it's doing great. It really is.
Saves a lot of money,
Yep.
at least in operations, that's for sure.
Yep. Yep.
Yeah. I don't know how the electric is going to work yet. Yeah.
Yeah, I think that again, just as part of geography is many of these pilot organizations are really remote. Sabine, for example, or Corpus Christi, they don't have the infrastructure that could support that yet. Could it happen? Yeah, sure it could, but they're or Venice, Louisiana, where those pilots go from. It's an hour and a half, 2 hours from any major civilization. Beautiful down there, but it's a long drive. So that's again the plays into the decisions that they make.
It might come into, my guess would be California first, like the Port of Los Angeles.
Yeah.
You know, the pilots at the Port of Los Angeles, the pilots can sit in their office and, you know, see the ship that they're going to pilot into the harbor. And so before they have to go out and get on board. So it's a pretty short run for those guys. So it might work out there.
A lot of what we're doing now, new technologies, including ride control, is all pointing towards crew comfort and pilot comfort and fatigue. It's all about fatigue, and so there's a lot of emphasis on noise abatement.
Yeah.
There's a lot the pilots. Oh my God, if the pilot seats that they make today are just unbelievable. When I think back to the best thing they had back in the day was what, a bus seat, right? A
Bus
transit
seat.
bus
Yeah.
So they have come a long way, and they've got shock mitigating seats. Peter was talking about back in the day with the simple pilot boat. Back in the day, the helmsman didn't even have a chair.
No, he didn't even have one. No.
It was if he was lucky, he had a wooden stool.
Right.
So now the helmsmen are also in the same high level seating as the pilots are. And again,
the other thing that we haven't mentioned is, of course, the emissions and the Tier 4.
Yeah.
Right.
That's right.
Is hitting us.
Good one.
Is you know, complicating the boats, making them more expensive and heavier, and that's going to have an effect. You know, we're really doing our first Tier 4 boat right now, right?
Yep. The Lake Charles 70-foot Lake Charles boat.
Right. Yep. So we'll see how that works out. But those systems are complicated, really nasty.
Yeah, for the Lake Charles boat, is the propulsion has the engines been picked on selected on that yet?
Yeah, it's Cummins QSK 38s. They came to us. We delivered a boat. It was a tier 3 boat. 4 years ago now, and they love it. They said, we want the same boat. I said, well, you can't have it because we're now into Tier 4. And they said, well, is there a way we can fit it in this existing boat, which we love so much? We said, well, let's think about it. So we went away and said, well, maybe if we reduce, it has quite a bit of fuel, which they don't always use. It's primarily for hurricane mitigation, right? So we said, well, if we offset the weight of the exhaust after treatment system with fuel, and if you can live with, you know, a 700, 800 gallons less fuel, it'll be basically the same boat, right? So as far as what you feel, so that was the mission we were given, was to take this. Of course, then the real work began. It had to fit all that stuff in the boat and design to make it so it floats right and everything else. So but as far as they're concerned, our goal will be for them to get on that boat and it'll feel the same or better.
Right.
That's interesting. Hey, Winn, just to follow up with you really quick. Now, you had mentioned the cost and the complexity of designing a Tier 4 boat. Can you kind of flesh that out a little bit? What additional things are you looking at and when you talk about the design and build?
Oh, well, it's mostly the additional cost is of the SCR systems that are going in. And then our challenge is fitting them in, you know, in probably an existing engine room. And there isn't a lot of space. And then getting the weight and trim right on the boat, because they're big and they're heavy, and they make more of a challenge of that.
Okay.
Just more complexity is what it amounts to.
Yeah, no, I get you. Well, it's not even close to the same thing, but I have a 33-foot 2008 boat, and I had to fix the vac flush this year. And when I say it was jammed into a place that no human being should have to be,
that's why people sell boats.
Hey, I've been doing this 33 years. I know just enough engineering to be completely dangerous, but that experience in itself gave me more respect for design, construction, and maintenance than anything.
Yep.
So
that's one feature of the Gladding-Hearn boats that we haven't really touched on, is that those boats are built in such a way that they can be maintained.
Mm.
And there's space, there's room. They don't bury the wiring behind panels that you can't get to them, and the plumbing comes apart easily, goes back together simply. And it's all very well thought out for maintenance in the long term. And I
Yeah,
think that's one of the things that the customers really appreciate, because
Yeah,
they're,
at the end of the day, that's right. And what makes a boat reliable and
Yeah.
low maintenance are the mechanical systems, right?
That's
It's getting all that from the machinery side of things, the plumbing, the piping, the items that might be sort of
that's a lot of
semi-disposable.
feedback that you
Yeah,
get.
that's
You
right.
get, the pilots come back and say, well, gee, you got to move this generator, 6 inches further away from the bulkhead or something like
Right,
that.
right.
Otherwise, we can't change the water pump. You got to do this.
Yep.
So we
Yep.
learn those things from them, from the pilots, really.
Right, and we welcome that feedback, and
Yeah.
and so when folks ask, how long does it take to build a boat? It depends on how much feedback you want to give, and the design process is really where you get it right. If that's not right, no matter how skilled you are at building a boat, it won't be right. So you got to start with a really good design, with a good hull design, structure design, mechanical systems have to fit into that, and then you give that to the talented people in the shop to execute it, and then that's what you get. But if any one of those is wrong, it doesn't matter. It's not going to be right.
Right.
So,
but of course, today, unlike in the early days of designing these boats, the systems today, the whole boat is designed before they start cutting metal, and they know where all the pipes are going to go, and they know where all the wires are going to go, and all that is in the design today before they even start the boat. Years ago, if we would be designing the boat and feeding them plans to try to stay ahead of the guys out in the shop with the cutters and the welders, the planning today is much greater than it used to be. It's just,
well, the expectations is going to be perfect, right? And while we do many things similar, we say we never do the same thing once. And it's true. And it's you take a car, truck, bus manufacturer, they build dozens or hundreds of a particular, thousands even in some cases, and they build prototypes and they spend millions of dollars developing it. And then you don't have a lot of options, right? You come to us, you can get within the laws of physics, you can get pretty much anything you want, and maybe we're too generous with that, and that's our problem. But I'd love to be able to build the same boat many times over and over again, the same design, and that happens quite a lot, with government contracts in smaller boats. But for the types of boats that we're building, the size range, there really aren't that many opportunities for that to happen. So we've had to learn to get good at listening to our customers and using what we call flexible standards. For example, a lot of the mechanical components will be on all of our boats. A circuit breaker is a circuit breaker, a pump, or a valve, pipe fittings. We know what's good, and we know what's reliable, and we know what it costs, we know what it weighs. So we tend to use components on all of our boats that are the same, because we know we can rely on them.
That's excellent. I like that. Within the laws of physics, we can fit it on. That's
Well,
absolutely.
we get asked to bend them now and again, and we have to push back. So
Yeah. It's only certain things you can do. So,
right.
gentlemen, as I said, and again, this is spectacular insight. I really do appreciate it. And quite frankly, I think you three should do like podcasts together. You play off of each other very well. I very much appreciate that.
This
So,
is not rehearsed.
no, I know that's why it's a good thing. Trust me. So, gentlemen, I recently interviewed Whiting Chisholm of the Virginia pilots, and he was effusive in his praise for the Chesapeake class of pilot boats. Can you discuss the class? And again, I know going back to what Peter said before, that's a unique boat, but can you discuss specifically the class in detail, the number of references in the market, and the outstanding design and construction characteristics that perhaps we haven't discussed already?
Well, first of all, they have Chesapeake class boats, like many of our others do, but they also have that harbor class boat, which is a little bit different than any of their others. So I'm not sure exactly which one he was so happy about, but they're happy about all of them. They have some different generations of boats. They've got, propeller-driven Chesapeake class boats. They have IPS-driven, a little bit bigger boats, and then they have a jet boat for a small jet boat, and then they also have the harbor boat. So they've got good variety of boats from 40 up to 56 feet and different, for different applications.
I think the Chesapeake class, the 50 has evolved, since from the original Delaware, which is a 50-foot boat. I think overall as a size and type, it's the 50-footers have evolved to suit the needs of most pilot organizations. It's big enough to go offshore, fast enough, comfortable enough, but yet not so big as to be expensive to buy and maintain. I think that's probably the sweet spot of pilot boats.
Agreed.
In the 50-ish foot range, and as Peter says, they can be powered differently with jets or props or pods, but the basic design, I think, in that class 50 feet, 50 something thousand pounds, 30 knots capability, that allows most pilots to solve their problems.
When you look at your order books today, respectively, what's it look like in the pilot boat sector? And I guess when you look ahead, what opportunities do you see ahead?
Well, we've got 1, 2, 3, 4 under contract right now. And we are talking. We're always talking with our repeat customers about what the next project might be. There's a lot in flux right now with the right whale legislation. There are folks that it was stalled. There was supposed to be a change. They wanted 40 feet, 36, 35 feet and 10 knots or something. That was the break point. Right now it's 65 feet and 10 knots in certain whale areas. So we have some folks that would like to go bigger and faster as their sea buoy moves out, but they don't know what that boat will look like. Could be a 10-knot boat, for all they know. I hope not, because it's it's going to send us back 40 years in time. So there's a little reluctance there to commit, but at some point, the boats get old. They need to be replaced. They run 3,500 hours a year, and they wear out. And the other thing we do have that we do a lot of, I should mention, is refit. At 10, 15 years. The boats still have really good, say 15 years, the boats they're worn out. They need new machinery. Hatches, doors, windows are worn out, electronics and seats, interior, whatever. They're tired. They've got a lot of hours on them. So many times we'll take them back and do a complete refit on them and make them nearly a new boat with new machinery, new marine enclosures. Spruce up the interior, new seats, electronics, all that sort of stuff. New paint job, maybe a little bottom plating here and there, fendering system, steering, all the stuff that just wears out, and it's nearly like a new boat. And it's typically around half the cost of a new boat in that time, and so it's worth doing. The boats have really good bones, and it takes less than half the time to do it. So it's a good option, and for many organizations to do that. Some choose to just sell them and build a new one, and that's a good option too. So we do all of that. So.
Thank you for listening to Maritime Matters. If you would like to be featured on a future Maritime Matters podcast, visit www.marinelink.com or email maritimematters@marinelink.com.